In this video, we will demonstrate how users can define the links between equipment parts in ADAMS to the equivalent parts in the EDAM simulation. The co-simulation is performed using the ADAMS Co-Simulation Interface, also known as the ACSI. By creating a link between the parts, ADAMS will be able to control the motion, and EDAM will provide the realistic material force feedback. Before linking the parts, you must ensure that you have imported the CAD files for your geometry in both ADAMS and EDAM. To start the co-simulation setup, go to your model in ADAMS view. The links between the parts are based on general force vectors assigned to the center of mass of the equipment parts in ADAMS. These force vectors are also known as G-force markers. From the Forces toolbar, create a G-force marker that is located at the center of mass of the equipment part. Select the ADAMS part, then the ground part, and then the center of mass marker of the part being coupled. Repeat this process for each of the equipment parts you want to link to EDAM. Once created, each of the G-force markers is listed in the model tree on the left-hand side. The next step is to assign the appropriate settings to these markers. Right-click on one of the markers you have created and choose Modify. In the window that appears, change the Define Using option to be Subroutine. Set the user parameters value to be 0, and then enter the routine to be ACSI_ADAMS, followed by 2 colons. Click OK and then repeat for all other G-force markers. Next, we need to save the model for use by the ACSI. From the File menu, choose Export, and select the file type to be ADAMS Solver Dataset. Make sure Export All Graphics is selected, but deselect the Verify Model option. Make a note of the model name and file name used, and click on OK. Following this, we need to configure the ADAMS command file. Browse to the folder for your ADAMS simulation and open the ACF file in a text editor. Enter the ADM name and the model name. Next, enter the total time the ADAMS simulation needs to run for, along with the number of steps that are required in ADAMS to reach that time. Finally, save the file with an appropriate name. The next step is to edit the co-simulation file. From your ADAMS model directory, open the blank .cosim file that was provided with the EDAMS installer in a text editor. Next, make the following changes. Define a process name for the co-simulation. This is used as a reference by the ACSI and can be anything. Under the ADAMS process section, enter an ADAMS process name. Again, this is used as an identifier and does not need to correspond to a simulation name. In the execution command instruction, firstly make sure that the correct path is defined to the MDI batch file. This will depend on the version of ADAMS you are using. Next, enter the name of your ACF file that you saved previously. And lastly, in the ADAMS process section, enter the correct working directory for your simulation. Next, the user needs to define the links between the ADAMS equipment parts and the equivalent EDAM parts. This is done by defining named interactions between parts. This needs to be done both in the ADAMS and EDAM process sections of the COSIM file. Starting with the ADAMS process section, under the name variable, enter a name on the ADAMS side that you would like to use. Under the connection variable, enter a name of the equipment part in EDAM that is to be linked. For ease of identification during a later step, it is recommended that you include ADAMS and EDAM underscore ahead of any name. Finally, under the G-force ID variable, enter the number of the corresponding G-force in ADAMS that was created previously. If you are wanting to link multiple equipment parts in the co-simulation, an interaction function needs to be defined for each part in the co-simulation file. The easiest way to do this is to copy and paste the lines of code for the existing interaction function and update the variables with the correct part names and G-force marker ID numbers. We now need to define the corresponding interaction relationships in the EDIM process section. First, update the EDIM interaction name variable to be the same as the corresponding EDIM connection variable we defined earlier. Next, update the connection variable with the name of the atoms interaction. For both these names, it is important to ensure that they are the same as used in the atoms process section. Finally, in the EDIM interaction, we need to define the geometry name variable. This variable is the name of the EDIM equipment part that you want to be controlled by atoms. The name here is case-sensitive, so take extra care to make sure it is defined exactly as it is entered and EDIM. Repeat this process to add all remaining interactions. Save your co-simulation file. Finally, we need to define some environment variable information. First, open the environment variables text file that was supplied with the installer and copy all the contents. Next, open the Atoms Model ADM file in a text editor. Paste the information from the environment variables into the System Units section of the ADM file. Update the environment variables with the name of the COSIM file, making sure that the file name is written between quotation marks. Save the file and close.